Hello guys, so in this video I will be going over trigonometric identities. We have two trigonometric identities in our AS syllabus. The first one is that tan theta is equal to sine theta over cos theta. So sine theta over cos theta, and the second one is that sine square theta plus cos square theta is equal to 1. Okay, so the first question we have is from October-November 2002. So this question says that we have to show the equation 3 tan theta is equal to 2 cos theta as 2 sine square theta plus 3 sine theta minus 2. So basically we have to introduce sine to the equation by eliminating tan and cos. So we cannot directly omit cos and introduce sine, but we can do that with tan by using the first identity, which is that tan theta is equals to sine theta over cos theta, right? So we are going to use that identity over here. So 3 instead of tan we will write sine theta over cos theta, which is equal to 2 cos theta, right? So if we multiply this over here, then we'll get 3 sine theta is equal to 2 cos square theta, right? And then by the second identity we know that sine square theta plus cos square theta is equal to 1, right? Then we can restructure that identity by making cos square the subject. So if we make, so the identity is that sine square theta plus cos square theta is 1, right? So if we rearrange this identity and make cos square the subject, then we know that it will be equal to 1 minus sine square theta, right? So in this equation, instead of cos square theta, we will write 1 minus sine square theta. So we have 3 sine theta, and instead of cos square theta, we are going to write 1 minus sine square theta. Now we will multiply 2 to both the terms. So 2 1s is 2, and 2 times sine square theta is 2 sine square theta. Rearrange the equation again. So we have, if we bring this thing to the other side of the equation, then it will be positive. So it will be 2 sine square theta, we have a square over here, 2 sine square theta plus, we will copy this, 3 sine theta, and then we'll bring this to the other side of the equation. So minus 2 is equal to 0. So we have shown that this that 3 tan theta is equal to 2 cos theta can be expressed as 2 sine square theta plus 3 sine theta minus 2 is equals to 0. So you can write shown, right? Okay, so our second question is from May-June 2002, and it says that we have to show sin x into tan x, that it can be written as 1 minus cos square x over cos x, right? So the same thing goes for this. We cannot directly express sin x as cos x, but we can express tan x in terms of cos x, and we will do that by using the first identity, which is tan x is equal to sin x over cos x, right? Oh, I'm sorry, this is sin x over cos x. So instead of, so we will just copy down the sin x over here, and instead of tan x over here, we will just write into sin x over cos x, right? So the sin x are both in the numerator, so they get multiplied, so this becomes sin square x over cos x, right? And then using the second identity, we know that sin square x plus cos square x is equal to 1, right? So if we make sin square x the subject of the equation, then this becomes sin square x is equal to 1 minus cos square x. So we replace this in the equation, and instead of sine square x we write 1 minus cos square x over cos x, and we have shown. So you can simply write here shown. Okay, so our next question is from October-November 2003. It says that 4 sine 4x 4 theta plus 5 is equal to 7 cos square theta may be written in the form of 4x square plus 7x minus 2 is equal to 0, where x is equal to sine square theta, right? So the key is to first express the equation in form of sine square theta. So let's just copy down the equation. So the equation is 4 sine 4 theta plus 5 is equal to 7 cos square theta. Okay, so this thing is already in the form of sine square theta, because if we square sine square theta, then the powers will multiply, right? So this becomes sine 4 theta, right? So this is, we can simply just write this as 4 sine square theta squared. What we have to take care of over here is that this thing is in the form of cos square theta, and we have to transfer it in the form of sine square theta, or express it in the form of sine square theta, right? So we will do that by using the second identity, which is sine square theta plus cos square theta is equal to 1, and we have to express cos square theta in the form of sine square theta. So we will make cos square theta our subject. So this becomes cos square theta is equal to 1 minus sine square theta, right? So we will just copy plus 5 down, and then 7, and then instead of cos square theta we will write 1 minus sine square theta. So the 7 gets multiplied to both 1 and minus sine square theta. So we will copy this part of the equation as it is, right? So this becomes 4 sine square theta, which is squared, plus 5 is equal to 7 minus 7 sine square theta. And then the same thing happens, we just copy down this part of the equation, sine square theta, and this is squared, plus 5. Now we will take these and transfer them over here. So minus 7 plus 7 sine square theta, right, is equal to 0. Then we rearrange the equation, so this becomes 4 sine square theta squared plus 7 sine square theta, which will be plus 5 minus 7 is equal to minus 2 is equal to 0, right? And they are saying that x is equal to minus sine square theta, right? So every time we have sine square theta, we will just replace it with x. So we will replace this with x, this with x, and that's it. So this becomes 4 x squared plus 7 x minus 2 is equal to 0. We'll just remove the bracket, so this becomes 4x squared plus 7x minus 2. So we have expressed this equation in this form. So we'll write shown. Okay, so we have our next question from May-June 2004, and in this question they want us to express sine square theta plus 3 sine theta cos theta is equal to 4 cos square theta as a quadratic equation in tan theta, right? So basically we have to eliminate all sine thetas and cos thetas and introduce tan theta. So what we can simply do is we can divide this cos square theta throughout the equation. So if we do that, we will have something like sine square theta sine square theta over cos square theta plus 3 sine theta, cos theta. This all will be divided by cos square theta. And this is equal to 4 cos square theta will be divided by cos square theta, right? So this will simply just get cancelled out, and because our first identity is that tan theta is equal to sine theta over cos theta. So if we square both sides, then we will have something like tan square theta is equal to sine square theta over cos square theta. So over here, instead of sine square theta over cos square theta, we can simply write tan square theta. So that's what we are going to do. We are going to write tan square theta plus, so here we have cos square theta, right, in the denominator. So we can write this as sine theta over cos theta, one for this one, and the other one, oh sorry, there is no, yeah, and the other one is cos theta, this cos theta over the other cos theta from this cos square theta. So this one gets cancelled out, and this one, because of the first identity that tan theta is equal to sine theta over cos theta, we can replace this with tan theta. So 3 tan theta, right? And this will be tan square theta. I have just copied it as it is, plus 3 tan theta, and here we have is equal to 4 because the cos square theta got cancelled out. Then we just bring this to the other side of the equation, so this becomes tan square theta plus 3 tan theta minus 4 is equal to 0. So we have expressed the original equation in a quadratic equation in tan theta. So you can say shown. That's it for this video. I hope you learned something and now can solve these questions just as well. Goodbye.